Given that rows are horizontal and columns are vertical.
Oh, I could
What?
I could have just read that.
You could have just read that?
Yeah.
Okay. Yep, those are the directions. How many columns are needed to place 20 people in 4 rows? It would be 5, right? Okay. Could I have done that without sketching it out? By just doing what? 20 divided by 4, yes. Okay, but it did ask me to sketch it out. I see some people are drawing grids. Some people have drawn just dots. I'm going to do dots just because that seems like it'd be easier, but regardless, you should have had some kind of sketch that had 5 vertical columns and 4 horizontal rows. Okay, 20 dots total, or 20 whatever total. Okay, and then the next question asked me, how many rows are needed to place 12 people in 2 columns? What do we think? 6. 6 rows, okay, 2 columns. So again, rows are horizontal, columns are vertical. Okay, that gives me 12 total. If people are aligned in 3 rows and 5 columns, you could have drawn it, but it didn't say you had to. With every place taken, how many people are there total? 15. How'd you find that out? Math. 3 times 5. Could I put 25 people in an equal number of rows and columns? How? It would be a 5 by 5. Good. Okay, 5 rows by 5 columns. Perfect. That would work. Okay, the second question asked me, what about 10 people? Could I do that with 10 people? Equal number of rows, equal number of columns. How? I see heads shaking. Okay, not for 10. It wouldn't work. Okay, there's no 2 of the exact same number that multiply to give me 10. What about 6? Not 6 either. What about 4? Yes, it would be a 2 by 2. 2 by 2. Are we all okay with that?
Absolutely.
We're picturing what a equal number of rows and columns looks like. Perfect. Okay. And then number 5, it told you to pick out 6 names and place them in a setup made of 2 rows and 3 columns. Okay, let's do it. Give me some names. Radley? Give me another name. Mackenzie. Keep going. You're a nice friend. You're just picking your whole table. Zoe? Who? I still don't know who you said. Braden. I thought she said Brandon. I was like, there is no Brandon in this class. And the last one? Lexi. Okay, cool. All right, what person do we have in row 1, column 2? Row 1, column 2. Mackenzie. And what person do we have in row 2, column 1? Zoe. Okay. So just by that exercise, it really matters when we're saying as far as what row number, what column number, that matters as far as location goes, right? Okay. This leads us into what this next unit is about what we call matrices, or a matrix for the singular form. What a matrix is, it's an array of numbers or expressions or variables shown in a rectangular setup of rows by columns. So that is something I want you to write up here. All right, guys, I need the side conversations to turn off. Okay, once again, rows by columns. Say that with me. Rows by columns.
Rows by columns.
Thank you. Okay, that matters. It is always rows by columns. Okay, how do I remember that? I don't know. RC. There's like a soda called RC Cola. Maybe that will stick in your brain. Okay. But whatever you do, don't flip them because this is important, okay? Dimensions, okay? This is, once again, rows by column. So if I asked you for the dimensions of this example right here, how many rows does it have? 4. And how many columns does it have? 3. So the dimensions for this example would be a 4 by 3 matrix. Okay. We have a couple different types of matrices, okay, that are special kinds. The first one is called a square matrix. This is like our warm-up question we talked about, okay? Equal number of rows, equal number of columns. Okay, so an example of a square matrix, okay? I could have a 2 by 2. I could have a 3 by 3. I could have a 4 by 4, a 5 by 5. Hopefully you're sensing a pattern here, okay? But once again, they've got to have equal number of rows, equal number of columns. Looking at my example, is that a square? No. It is absolutely not. Okay. The next special type we have is called a column matrix. Okay. This is where we have one column. It doesn't matter how many rows there are. Okay. It could be a lot or it could be a few, but it's just going to be one column. Okay. So for instance, if I had something that looked like this, A, B, C, D, okay. That would be a column matrix. It's one singular column, and that's it. No other columns. Okay, then we have what's called a row matrix, and hopefully you could take a wild guess at what that's going to look like. Okay, instead of one singular column, it's going to be one row, one horizontal row. Okay, so again, I'll just use this exact same example because it sounds easy. A, B, C, D, okay, or 1, 2, 3, 4, whatever it is. It's one row, and that's it. Okay? And then lastly, we have a way that we can talk about just the singular elements that are in this, okay? And how we do that, how we notate that is that we have just the lowercase a, and then we have row, column, okay? So another way that you could write this, instead of M and N that don't really make a whole lot of sense, you could put RC there just to help you. Okay, what I mean by this, let's go do a few examples with our example. Okay, if I asked you in this specific matrix, okay, what is element 1, 3? Okay, I'm asking you which element is in row 1, column 3. Yep, Maddie says negative X. I agree. Okay, let's do another one. What element is element 3, 3? 7. Good. That's in row 3, column 7. Okay. And lastly, we'll do one more. What about 4, 2? Element 4, 2. 12. Okay. Perfect. This should be pretty straightforward, pretty simple. What questions do we have?
Double digits.
What if we have double?
Do you just put a comma between them?
Yeah, you'd probably see a comma between, but we're not actually going to deal with anything that big this unit. So, yep. Good question. Okay. Any other questions? Nope. Okay. Here are 4 problems. I'd like you to do this for me. I'm going to pause the video. All right, stating the dimensions. What are the dimensions of this? A 3 by 2. 3 rows by 2 columns. That's all that means. It's a 3 by 2 matrix. Okay, and then it asks me, what is element 2, 1? Yep, row 2, column 1 gives me 4. Good. Number 2, what are the dimensions of this? 2 by 3, 2 rows by 3 columns. And element 2, 1 over here is going to be what? What? 2, good. Row 2, column 1 gives me 2.
That's right.
Okay, one thing I want to point out, because I hear a little bit of frustration, okay? Up until this point in math, okay, 3 times 2 and 2 times 3 have always been the same thing, right? Okay, because that looks like multiplication, right? Multiplication's commutative. We know 3 times 2 is 6, 2 times 3 is also 6, okay? When we're talking dimensions of matrices, these are not equal, okay? And I can see that clearly here. Is a 3 by 2 matrix the same as a 2 by 3 matrix? It is not, okay? So this is a different kind of math, okay? A different type. So when we're talking about dimensions, we're not talking about necessarily a multiplication problem here, okay? Even though 3 times 2 gives me the amount of elements that are in this matrix, there's 6, right? There's 6 in both. It's giving me the dimensions. They are not equal, okay? Does anyone have questions on that? Okay. Number 3, is this a square matrix? No, it does not have equal number of rows, equal number of columns, okay? Is it a row matrix? Yes, why? Yeah, it's one singular row. Is it a column matrix? It is not, okay? It's got 2 columns. So, will every matrix be one of those 3 special types? Absolutely not. We just saw the example on the last page was not any of those things, okay? But these are just my special cases. So square, equal number of rows and columns, row is 1 row, column is 1 column. Are we clear on that?
Yes.
Okay. Number 4, this asked me to create a square matrix that has the following elements. How big, dimension-wise, did this have to be?
3 by 3.
It had to be at least a 3 by 3. Could I have made it bigger? Could I have done a 4 by 4 or a 5 by 5? Yeah, but at that point, I'm just doing more work, right? Okay, so a 3 by 3 would definitely be a good option. Okay, that's the minimum you could have gone. Element 1, 2 is 14. Where's that going to go?
Right in the middle of the top.
Middle of the top. Element 2, 1,
On the left-hand side in the middle.
left-hand side in the middle. And 3, 3.
And the very bottom left, right.
Bottom right corner, I love it, okay? Should I just leave blanks for all the other elements? No, I need to put something there. Does it matter what it is? No, we don't know what it is. What'd you put? You put X's, that's fine. You could have put zeros. Yesterday, a lot of students chose 6s and 7s, okay? It really does not matter. It's whatever you want to do. Leave it to you. Okay. What questions do we have? Are we good with that? Okay. Last couple things today. Told you today was going to go quick, and it is. First one is matrix addition and subtraction, okay? There's one part here that I want you to underline, highlight, star, whatever you got to do. When we add or subtract, they must have the same dimensions. They have to have the same dimensions, okay? If they don't, you can't do it. It would be what we call undefined, okay? It just cannot do the operation is what that means. Gotta have the same dimensions, okay? And if they do have the same dimensions, then we're just performing whatever it is, addition or subtraction, on the corresponding elements, okay? So what I mean by corresponding is if it's element 1, 1 in the first matrix and we're adding, I would add it to element 1, 1 in the second matrix. Simple as that, okay? Scalar multiplication. This is very, very simple. All it is distribution. Okay, if I'm multiplying a matrix by an outside value, I'm just distributing to everything inside of it. And then lastly, if I have 2 matrices that I tell you are equal, okay, I can set the corresponding elements equal to each other as well, okay, which should make sense, and we'll see an example of that on the next page. Okay, we're going to start off with, what operation is this? Addition, yep, okay. Can I add these 2 matrices? Yes, because they have the same dimensions, right? What are those dimensions? 2 by 2. So my answer is also going to be a 2 by 2. And then I'm just adding up the corresponding elements, okay? So what I mean by that? -4 plus -6. What is that? -10. Cool. Then I've got -4 plus -5, which gives me -9. You do the second row. Okay, row 2, element 1 is going to give me 3. And last but not least, I've got row 2, element 2, -5. How'd we do? Is that pretty easy?
Very easy.
Very easy. I like it. Okay. Then we go to number 6. Got a -4 on the outside of a, what are the dimensions of that? 2 by 2. So my answer is also going to be a 2 by 2. And I'm just distributing that -4 to everything inside of there. So, first element, -4 times 3 is -12, right? Okay, you finish that. Do the rest of them. Okay, what else is on the top row? We got -12 and 24. Bottom row,
-20 and 20.
-20, +20. Cool. How'd we do? 2 negatives make a positive, right? Don't forget that, okay? Cool. Any questions on this so far? All right, I'm gonna give you a couple minutes. I'm gonna pause this video. I want you to do 7, 8, 9, and 10. Try your best on it. You're welcome to work together. Alrighty, let's turn our attention to number 7. What do we got? -16 minus 4n. And -4n squared. Good deal. Any questions on that? How'd we do? Okay. Number 8. Can I add these two? Yes. Okay. They have the same dimensions, right? Okay. So we look at our first element. M plus 2m. What's that going to give me? 3m. Thank you for not saying 2m squared. Okay. We never, ever, ever add exponents unless we are multiplying. So if we're adding, we don't add exponents. Okay. Good. So that is just adding 1m plus 2m, 3m. Okay, what about 3n plus nm? Are those like terms? No. Okay, so what do I do with them? Just keep them separate, like that. Okay, and then lastly, I've got 6m and -5m. What's that give me? Just a 1m. That's it. So just a reminder, to be like terms, we've got to have same variable and same exponent on the variable. Yep, what's your question?
Do we just not add the n to the 3n?
You can't, because these aren't like terms, because they don't have the same variable. They have the n in common, but they don't have, one of them has nm and the other one doesn't have m. So that's why we can't add them. Okay, good question. Okay, any other questions on that? All right, number 9, what do we think? Why is it undefined? Yeah, not the same dimensions. Have to be the same dimensions to subtract. And then lastly, number 10, can I subtract those? Yes, and we haven't done subtraction yet. Okay, so let's see how we did. My answer is going to be what dimensions? Yeah, also 3 by 2. And let's go for it. Okay, starting with 1 minus -5. What do we think that is? It is 6. Good. 2 negatives make a positive when you're adding and subtracting as well, right? Okay, if I subtract a negative number, that turns into a plus sign. So that ends up essentially being 1 plus 5. Are we good with that? Okay. You guys are doing well. My class yesterday thought that that was made up. Okay. -2 minus 1. What do we think? -3. Cool. Next row, what do we got? -5 minus -4. -1. Okay. Row 2, element 2. 9. Good. Row 3. 1. And lastly, 2 minus a -2 is 4. Good deal. How do we feel about that? best piece of advice is just to go slow. This is not a rush. It's not a race, okay? There's no award for who gets done with the test the fastest, okay? A lot of times it's really easy to make mistakes if we just speed through that. All right, and then lastly, using the matrix or matrices to find the values of variables if I have these set equal to each other, okay? I don't know what's going on over here. Okay, so if I tell you that matrix A equals matrix B, I can solve for these unknown variables by just setting the corresponding values equal to each other, okay? What variables do you see in here? Okay, we see X, we see Y, we see W, and we see Z. Okay, cool. We'll start with X. I'm going to do that one with you, and then I'm going to let you do the rest on your own for a sec. Okay? If I look, where is X? Yeah, element 1, 3, right? Okay, so I can set that equal to element 1, 3 over here if these matrices are equal. So that's just setting up this equation. And how would I solve that? Yeah, divide by -1, and what's X equal? -7, easy as that. That's it. Okay, so you're going to do the same thing with Y, W, and Z. I'm going to give you a few minutes. I'm going to pause this. All right, Y. What are we doing for Y? What are we doing for Y? How do I set it up?
Y plus 2 equals 3y minus 1.
And how do you solve that?
Add 1.
You could add the 1 over and subtract the Y. That works.
Then you get 3 is 3.
3 equals 2Y. And then what? What do I do from there? Oh my gosh, we need to go back to pre-algebra. Divide by 2.
Actually, I need to go first.
And what's Y equal? 1.5. Perfect. Okay, if you left it as 3 over 2, that's also totally fine. Okay. Next letter we said was W. What are we doing there? W squared equals 36.
So then she's got to square root it.
And then you just gotta square root it. That works. What's that give you?
6. For W equals 6.
Good. 2 answers, right? It was W squared. So that's going to give me plus or minus 6. Positive 6, negative 6, okay? The other way you could have done that, you could have subtracted the 36 over because we see that we have a higher exponent, which probably means we could do factoring to solve it, right? Okay, which is still going to have me square rooting. I get W minus 6, W plus 6, and if I break those apart and set them equal to 0, I get 6 and negative 6, which is the exact same thing as what I got here, okay? Don't do it both ways. Just pick the way that works better for you. What questions do we have? Okay, last letter that we don't know is Z. Okay, I've got Z minus 1 equals Z squared minus 3. And how did we do this one? Impress me today. Thank you. Move everything to one side, okay? Which side did you move to? Yeah, I would agree. The right side, okay? Because this is going to be what? It's going to be an X method one. At least we hope it is. 3 terms. Move everything over and combine like terms. Put them in descending order. And set it up. What goes at the top? Negative 2 at the bottom. What's going to multiply to negative 2 and add to negative 1? Negative 2 and positive 1. Will the shortcut work? Yep. Okay, because this is a 1, I can just place my variables in front of my numbers. Here are my factors. And how do I find the solutions? Set them equal to 0. And it should be negative 1 and positive 2. I like it. We knew there would be 2 answers because highest exponent was 2. Same thing with the W. Okay, it was squared. We knew we were going to have 2 answers. How we feel on this? We feel good?
Those are for
Just low key easy?
you. Yeah.
Good. I'm glad I got that on the video. That you said that. I'm gonna quote you on it. Okay? What?
I said, well, I actually figured out what I was doing.
When you figured out what you were doing, it was easy. Good. I like it. Okay, let's take that that attitude and bring it into the rest of the unit with us these next couple days. Okay. Any questions before we end this? Homework is on Canvas. Get it done. It's short. You're welcome.